Good morning. We're looking at homework number 11, and in the Google form, a lot of you asked about problem number 11. So in a geometric progression, A1 is 4, A4 is 27, 5R. So I know that in order to write this explicit formula, A sub n will equal 4 times R to the n minus 1. That's using the order pair 1, 4. I now know 27 will equal 4 times R to the 4 minus 1. So that's 27 equals 4R cubed. I'm going to divide by 27 equals R cubed. Now it becomes just some manipulating. I do need to take the cubed root of both sides, and so the cubed root of 27 is 3. I actually can't take the cubed root of 4. So one of the things that we'll be revisiting in the next week, after we come back to school the next couple weeks, is how to simplify a radical like this. So I'm going to do the 3 over, and instead of leaving that as a 4, I'm going to leave it as 2 squared. And the process I'm getting ready to look at is called rationalizing the denominator. And so in order to cancel out a cubed root, I need to have my exponent be a 3. So instead of writing this as 2 squared, I need another 2, which means I'm going to multiply both the numerator and denominator by the cubed root of 2. So in the numerator, I will have 3 on the cubed root of 2. In the denominator, I now have 2 squared times 2. That's 2 cubed, and that's what I want because the cubed root and the cube will cancel each other out. And so there's your value for R. There's your value for R. I had a few of you ask me about problem 8. So as I look at 8, I know the sum. I do not know n, so I can't find how many pairs. For what each of those pairs will add to, I do know A1, but I don't know A sub n. So I have 2 unknowns. In order to deal with 2 unknowns, I need another equation that has the same 2 unknowns. And so I'm going to move my paper a little bit. I'm going to end up using the explicit formula there. I know the first term is 10, the nth term is A sub n, and I do know the common difference, that's 2. So A sub n minus 10 will equal 2 times n minus 1. So A sub n will equal 10 plus 2 times n minus 1. So I'm going to go and plug that in for A sub n. If I can't get both of them on the same screen. Let me move it out a little bit. There we go. So as I look at this, I'm also going to go ahead and multiply by 2 in this step because I really don't want to deal with that fraction. So that's 324 will equal n times 10 plus 10 plus 2 times n minus 1. And again, that's where I substituted in the explicit formula. So let me do some simplifying. 324 equals n. 10 plus 10 is 20. Let me distribute 2n minus 2. So 324 will equal n times 2n plus 18. I'm going to go ahead and distribute 324 equals 2n squared plus 18n. And one of the things I can do to make my life a little easier here is I see it's a quadratic, so I'll know I'll end up using quadratic formula, but I also see everything here is divisible by 2, and so that way I'll be able to work with lower numbers. 324 divided by 2 is 162. And then I'll have n squared plus 9n. So let me set that equal to 0. And since it's a quadratic, I can use a quadratic formula, so n will equal negative b plus or minus the square root of b squared, so that's 9 squared, 81, minus 4 times a times c all over 2. So negative 9 plus or minus the square root. Negative 4, I'm doing this in my calculator. So I ended up getting 729 for that quantity of the radical, and the square root of 729, that is a perfect square. It's 27 over 2. Now remember, n is the number of terms, and so if I took my first answer, negative 9 minus 27 over 2, that's not going to happen because that would make n be negative, and we can't have a negative number of terms, and so I'll just have negative 9 plus 27 over 2. And so that gives us 18 over 2. And so what is 18 over 2? 9. So n is 9. All right, so I had several of you guys ask about 12 as well. And so this is geometric. We can see r is negative 2. So I know 1,536 will equal negative 3 times r to the n minus 1. Oops. I'm using a pen too. I don't like using pens, but it shows up better in my document camera. I know r, excuse me. So I need to start getting the exponential term by itself. So I'm first going to divide by negative 3. So now one of the strategies you have is to make the bases be the same. So can you write negative 512 as negative 2 to the something? And if you think about that, I mean, you should know negative 2 to the 5th. You should know that one. That's negative 32. So just kind of go from there. 2 to this, negative 2 to the 6th, negative 2 to the 7th, and so on. And what you should find is that's negative 2 to the 9th. Now, I want you to look at this. So you've created an equation. Each side of this equation is equal to the other. So for these two sides to be equal to each other, the bases are the same. They're both negative 2. So what does that mean has to be equivalent? Well, that means that the exponents must be equal. So you should get n is 10.